Good day everyone, my name is Mah Hui Ching, my matric number is 292479. My project title is Performance Comparison of Machine Learning Models for Phishing Website Detection based on Multi-Layer Perceptron. My domain is phishing attack in cybersecurity. Phishing attacks have become one of the most common and dangerous forms of cybercrime today, with attackers deceiving people into sharing sensitive information by pretending to be trusted sources. Often, phishing is just the first step in a larger scheme, leading to more severe action like system intrusion. Once attackers gain access to personal information, they can use it to breach systems and steal more valuable data. This connection between phishing and more serious attacks makes it critical to detect phishing early on before things escalate. In fact, the number of phishing incidents has been rising sharply, with approximately 4.7 million phishing attacks reported in 2022. It is 1.5 times higher than in 2019. In the third quarter of 2023 alone, phishing attacks increased from 180.4 million to 493.2 million, a 173% rise. These alarming statistics highlight the growing scale of the problem. The traditional detection methods like blacklisting non-phishing websites are no longer sufficient to keep up with the evolving tactics of attackers. The main challenge is that this method can adapt quickly to new phishing strategies, leaving systems vulnerable. In this context, machine learning classifiers offer a promising approach to detecting phishing websites. By analyzing various features of websites such as URL structure, domain popularity, and HTTPS usage, machine learning models can be trained to distinguish between phishing and legitimate sites. The focus of this work is on employing machine learning classifiers, particularly the multi-layer perceptron, to improve the accuracy of phishing site detection. This solution aims to leverage supervised learning techniques to create a robust model that can identify phishing sites accurately. This is the Python coding. The first is the importing libraries include the pandas used to read the CSV file, sklearn including the code validation score is for performing code validation to evaluate the model's performance. Random forest classifier, SVC, K-neighbor classifier, decision tree classifier, Gaussian NB, and MLP classifier is the different machine learning classifier used to detect the phishing website. Standard scaler used for feature scaling to standardize numerical features. Symbol imputer fill in the missing value. Column, transformer, and pipeline allow the creation of a processing pipeline where the preprocessing step and the classifier are linked together. Accuracy score, precision score, recall score, F1 score is used to evaluate the performance of the classifier. DF-train and DF-test are the training and testing dataset routed from the provided file path. X-train and Y-train is the feature and labels for the training set. X-test and Y-test is the feature and label for the testing set. For the preprocessing setup, the symbol imputer is used to handle missing data by replace any missing value with the mean of that feature. And the standard scaler is used to scale feature by removing the mean and scaling to unique variance. After that is the classifier setup. There are 6 classifiers including the support vector, machine SVM, K nearest neighbors, KNN, decision tree, nav bias, random forest, and MLP, multi-layer perceptron. The MLP classifier is implemented using the scikit-learn library. The network uses the ReLU, rectified linear unit activation function, for the hidden layer, which help in avoiding the vanishing gradient problem. The solver used is LBFGS, which is efficient for small dataset, and the model is trained for up to 1,000 iterations to ensure convergence. For each classifier, a pipeline is created which first apply preprocessing and then train the classifier. The model is trained on the training data X train and Y train. Prediction: the trained model is then used to predict the test data, which is the X test. The model is evaluated using common classification metric, accuracy, precision, recall, F1 score. The model is also evaluated using 5-fold and 10-fold close validation to assess its performance more reliably. Close validation split the dataset into multiple folds, training the model on different subsets each time and help to reduce overfitting. And then the performance metric and training time for each classifier are stored in the result dictionary. At the end, the result for each classifier are printed to the console. This is the finding for all of the classifier, and we can conclude that the best performance is the MLP classifier with a test accuracy of 98%, precision of 96.93%, recall of 99.14%, and F1 score of 98.02%, along with consistent close validation accuracy of 97.67%. The random forest and SVM classifier also perform well with test accuracy of 97.14% and 97% respectively, and strong precision recall and F1 score. The decision trees show reliable performance, 96.86% accuracy, while the KNN achieved 95.43% accuracy. However, the net bias classifier underperformed with a test accuracy of 66.29% and poor recall 32.57%. Training times were shorter for net bias and decision tree, while the MLP provided the best balance of speed and accuracy.